Let's turn back the cosmic clock to a time when the universe was in its infancy, a time of profound mystery and wonder. We're going way back, billions of years, to a time before our sun, our planet, even our galaxy existed. Imagine a universe that was just beginning to take shape, a vast expanse of darkness and potential. This is the era shortly after the Big Bang, a time of immense darkness. The universe was a cold, empty place, filled with nothing but hydrogen and helium, the simplest elements. But within this darkness, something extraordinary was beginning to stir. The very first stars, the primordial stars, were igniting. These stars were the universe's first light, breaking through the cosmic night. These weren't just any stars, they were cosmic pioneers, blazing forth with a brilliance never seen before. Their light began to illuminate the vast, dark universe, creating the first beacons of hope in the cosmic sea. They were giants, far larger and hotter than any star we observe today. These massive stars burned with an intensity that is hard to imagine, their energy shaping the very fabric of the universe. Their formation marked a pivotal moment in the history of the universe, a transition from the Dark Ages to an era bathed in starlight. This was the dawn of a new cosmic era, where light began to dominate the darkness. These first stars hold clues to understanding our own origins. By studying them, we can learn about the processes that led to the formation of galaxies, stars, and eventually, planets. They were the universe's initial attempt at creating something from nothing. These stars were the first steps in a long journey that would eventually lead to the rich and diverse cosmos we see today. Studying them allows us to peek back into the earliest chapters of cosmic history. It's like reading the universe's autobiography, understanding how it evolved from a simple beginning to the complex structure we observe now. So come along on this journey as we delve into the fascinating world of primordial stars. We'll uncover the secrets of their formation, their incredible characteristics, and their role in shaping the universe. We'll explore their formation, their characteristics, and their profound impact on the universe we know today. Join us as we journey back to the very beginning, to the dawn of the cosmos. Imagine the universe just moments after the Big Bang. It's a hot, dense soup of elementary particles expanding rapidly and cooling down. As the universe expands, it cools, and these particles begin to combine. The first atoms to form are hydrogen and helium, the simplest and most abundant elements in the universe. These atoms, spread throughout the vast expanse of space, become the raw materials for the first stars. But it wasn't just about the ingredients. The universe needed the right conditions too. Gravity played a crucial role. It acted like a cosmic sculptor, pulling these atoms together into increasingly dense clumps. Over millions of years, gravity relentlessly drew in more and more hydrogen and helium. These massive clouds of gas, called protostars, became the seeds of the first stars. We often think of stars as fiery infernos, and they are. But their power source isn't fire, it's nuclear fusion. This process, happening deep within a star's core, is what makes them shine. In the intense heat and pressure of a protostar's core, hydrogen atoms are forced to fuse together. This fusion forms helium and releases an incredible amount of energy, the energy that makes stars shine. The first stars were almost entirely made of hydrogen and helium. Heavier elements like the carbon and oxygen that make up our bodies hadn't formed yet. This simple composition, combined with the immense pressure within these giant stars, dictated their unique characteristics. Primordial stars were not like the stars we see today. They were true behemoths, hundreds, even thousands of times more massive than our sun. Imagine a single star with the mass of a small galaxy. Their size also meant incredible temperatures. The surfaces of these stars blazed with a blue-white heat far hotter than our sun. Their immense energy output made them incredibly bright, but it also meant they lived fast and died young. These stars were short-lived giants, burning through their fuel reserves in just a few million years. Compare that to our sun, which has a lifespan of about 10 billion years. Section 5. A blaze of glory, the short lives and violent deaths of primordial stars. Because of their enormous mass, primordial stars consumed their hydrogen fuel at a breakneck pace. This furious rate of fusion produced immense amounts of energy, making them incredibly luminous but also shortening their lifespans. Eventually, even these massive stars run out of fuel. When that happens, the outward pressure from nuclear fusion can no longer counteract the inward pull of gravity. The star collapses in on itself, triggering a cataclysmic explosion known as a supernova. These supernovae were some of the most powerful events in the early universe. They scattered the newly formed elements forged in the star's cores far and wide. This enriched the surrounding gas with the building blocks for future generations of stars and galaxies. Section 6. Stellar Ghosts Seeking Whispers from the Early Universe. Directly observing these primordial stars is a challenge. These stars, known as population 3 stars, were the first to form after the Big Bang. They were massive, bright, and short-lived, burning out quickly and leaving behind little trace. They existed so long ago that their light has long since faded. The universe has expanded so much since their time that the light they emitted has been stretched and dimmed, making it incredibly difficult to detect. However, astronomers aren't without hope. They are developing new techniques and technologies to uncover the secrets of these ancient stars. They're using powerful telescopes to peer back in time, searching for clues about these ancient stellar giants. Instruments like the James Webb Space Telescope are designed to detect the faintest glimmers of light from the early universe. One method is to look for extremely distant galaxies. These galaxies formed from the remnants of the first stars and can provide indirect evidence of their existence. Because light takes time to travel, looking at distant objects is like looking back in time. The further away we look, the further back in time we see, allowing us to glimpse the universe as it was billions of years ago. By studying the light from these early galaxies, scientists can infer the properties of the stars that formed them. They analyze the light spectra to determine the chemical composition and age of these ancient celestial bodies. Another approach is to search for the remnants of primordial star explosions, like black holes. These remnants can tell us a lot about the stars that created them. These cosmic monsters are thought to be the remnants of the most massive primordial stars, their gravity so strong that not even light can escape. By studying these black holes, scientists hope to learn more about the first stars and the conditions of the early universe. Section 7. Cosmic Alchemy, the Legacy of the First Stars. Primordial stars were cosmic pioneers in more ways than one. They were not only the first sources of light, but they were also the universe's first alchemists. Deep within their cores, they forged heavier elements through nuclear fusion. These elements, including carbon, oxygen, and iron, were scattered throughout the cosmos during the star's explosive deaths. This enriched the early universe with the building blocks for planets, life, and everything we see around us. In a sense, we are all made of star stuff, the remnants of these ancient primordial stars. The atoms in our bodies were once forged in the hearts of these cosmic giants. Section 8, From Ashes to Life, the Building Blocks of Galaxies and Us. The death of primordial stars had a profound impact on the early universe. The supernova explosions that marked their demise seeded the surrounding gas with heavy elements. This enriched gas, in turn, provided the material for the next generation of stars. These later generations of stars inherited the heavy elements forged by their predecessors. They were also instrumental in the formation of galaxies, drawn together by gravity to form the grand spiral and elliptical structures we see today. Without primordial stars, our universe might still be a vast, dark expanse of hydrogen and helium. Their formation and demise were crucial steps in the long chain of events that led to the universe we know and love. Section 9. Unlocking the Secrets of the Primordial Universe. The study of primordial stars is a journey to the very dawn of time. These ancient celestial bodies hold the key to understanding the universe's infancy, a period shrouded in mystery and wonder. By examining these stars, we can piece together the events that led to the formation of galaxies, planets, and ultimately, life itself. It's a quest to understand the universe's earliest moments and the objects that shaped its evolution. These primordial stars, often referred to as population 3 stars, were the first to ignite after the Big Bang, and their light has traveled billions of years to reach us. While we've learned a great deal from theoretical models and observations, many mysteries remain. The exact nature of these stars, their composition, and their life cycles are still subjects of intense research and debate among astronomers. Astronomers continue to push the boundaries of technology and observation, seeking more direct evidence of these first stars. Advanced telescopes and sophisticated instruments are being developed to detect the faint signals from these ancient objects. New telescopes both on Earth and in space promise to peer even further back in time, capturing fainter light from the early universe. These cutting-edge tools will allow us to observe the universe in unprecedented detail, revealing the secrets of its earliest epochs. Each new discovery brings us closer to understanding these cosmic pioneers and their lasting legacy. The data collected from these observations will help refine our models of star formation and the evolution of the cosmos. As we continue to explore the universe, we unravel the story of our cosmic origins, a story written in the light of the first stars. This ongoing journey not only deepens our knowledge of the cosmos but also enriches our appreciation of the vast and intricate universe we inhabit.